There we've got exercise 9b for further mathematicians, looking again at polar graphs, and we've got three particular properties that I want us to look at. Number one is looking at greatest and least values. Number two is to look at symmetrical properties of graph, i.e. when can we prove that a polar graph is symmetrical, and also what the equations of the tangents at the pole. So if we just have a look at these three things. Now to do some of this, at least, certainly the maximum and minimum at the least and greatest values, we can use a method using our knowledge of trigonometric graphs and the fact that there are maximum and minimum values of these. For instance, the maximum you'll ever get with sine theta is 1. You'll get a 0, I suppose, but you can also get a -1 as well. It depends whether or not you're happy to accept negatives or not. So when do you get the maximum values? Well, you should know, for instance, let's do this in radians. You should know that this occurs, obviously if I just drew the graph, it would look something like this. So the maximum value occurs there, and that's at pi by 2. So that's where the maximum is. The 0, well, there's lots of zeros. I think it actually wants the minimum there, the negative value. And that occurs there, which is actually 3 pi by 2. So this is what I mean about finding the maximum and minimum values. Now cos 2x is a different ballgame, because although it's a cos graph, although it goes up to 1 down to -1, the 2x is like a transformation, it's like a stretch, well, a squash really. And so a cos graph generally looks like this. And what you normally do is it goes up to here at 360 degrees, or 2 pi. But because of that stretch by a scale factor of 1/2, it's only a pi there. And that means that's 1/2 pi, and this is pi by 4 effectively. So if that's the case, the minimum and the maximum values, well, there's the maximum. The maximum occurs, well, in two places at, I should really write theta equals for these, theta equals. Maximum is at theta equals 0 or at pi. But the minimum occurs, well, halfway point, theta equals pi by 2. Again, when do I get 3 sine theta? And I suppose I should actually, I just realised it says, what are the maximum and minimum values? Well, I'm kind of saying this, it's 1 and -1. I didn't hear, this is 1 and -1 again. 3 sine theta, it's actually just a sine graph again, it just goes higher. You can't really see that, but if I show that there, and 3 and -3, that's fine. And again, when do these values occur? Well, theta is pi by 2, and theta is 3 pi by 2. I nearly got that wrong. What's this one again? This can be thought of as being in a bracket. It's a cos graph. So it starts here, it goes down, and it goes round. Interestingly, this one, because it's divided by 2, it's actually a stretch by a scale factor of 2. So that actually goes up to 4 pi. So that's 1 pi, 2 pi, 3 pi, 4 pi. Its maximum is at 4, its minimum is at -4. So its max, when does it occur? Well, at 0 and 4 pi now. When does the minimum occur? Well, I reckon at 2 pi. See, I've got answers here. No answers at all. So anyway, we're looking now at symmetry properties of curves. Now this posh formula here, this bit I'm sort of circling, is actually the formula that we are meant to quote. And it says basically, if theta equals alpha is a line of symmetry. So if we suspect that, in this picture it looks like pi by 4, we suspect that there's a line of symmetry through this line, then we can test that premise by doing seeing what you would get if we put that angle into our function, and then seeing what we get when we put our angle into this function, f of 2 alpha minus theta, and see if you get the same answer. So if I show you what I mean by that, here's an example I've got here, show that theta equals pi by 4 is a line of symmetry of this curve. So this is, if you like, our function, and it basically, this is, if you like, our function f of theta, and it basically says, you know what, we've got, if I do f of theta, I know it's 2 sine 2 theta. That's what we've said here. But then what I also do is I find what f of 2 alpha minus theta is. And the alpha effectively is this. So this is my alpha is pi by 4. And what we can therefore do, if I know that my alpha is pi by 4, I can basically then say, well, I'm going to do f. And rather than putting just theta into my function, I have to put this weird 2 alpha minus theta in. So when I do this, of course, well, 2 alpha, by the way, is 2 lots of pi by 4. And that's like pi by 2, I would say. That's like 2 quarters minus, and it says here, minus theta. So I've got to put minus theta into my function. And of course, my function was 2 sine 2 theta, so it's 2 sine lots of pi by 2 minus theta. And it says 2 sine 2 theta, so I'm actually timesing that by 2 as well. So if I times that by 2, I get 2 sine, 2 lots of pi by 2, I reckon is pi. 2 lots of theta is 2 theta. Now you should recall, we've done it in normal maths. Now if you expand this, it's called an addition formula, or in this case a subtraction. And I get 2 lots of, and you get sine the first one, cos the second one, minus cos the first one, sine the second one. Now we should know a few things. We should know that sine of pi is 0, but that cos of pi, now remember pi is 180 degrees, cos of pi is, I think, minus 1. So if I put this in, I get 2 lots of sine of pi, I said, is 0. 0 times anything is going to give me 0. That's the nice thing about that. Minus and minus 1 times by sine 2 theta. So you'll notice here, I'm going to end up with, that is 0. And I'm going to get 2 lots of minus times a minus is a plus, so I know that, and then sine 2 theta. And I'm hoping you can see that that is the same as that. You'd probably finish off by saying, therefore, f of theta equals f of 2 alpha minus theta. Therefore, alpha, that's meant to be an alpha. Alpha equal to pi by 4 is a line of symmetry. That's what you're meant to do. Here's the posh answer if you want to check their answer against mine. And here's another example then. So again, exactly the same premise here. Perhaps you want to see if you can do it yourself, I don't know. But it says, show that theta equals pi by 2 is a line of symmetry of this. So again, I start off by saying, well, I know that f of theta is 1 plus cos 2 theta. And then I substitute into it. I say, well, what is f of 2 alpha minus theta? So what do we got? Well, our formula says 1 plus cos 2 theta, but let's just write this first of all. Now I know alpha is pi by 2, as I say, so I can say this is 2 alpha. Well, 2 alpha is pi minus the theta. That's what I'm subbing in really into my function. And of course my function's down here, so it's 1 plus cos. And I've got to do 2 lots of this. So I reckon that's 2 pi minus 2 theta. Now again, you should remember that this can be written, well, don't forget the 1 at the front, 1 plus, now cos formula goes cos of the first one, cos of the second one, and then you change the sign, it's a minus, so I'm going to write plus sine of the first one, sine of the second one. It's the same trick this really as last time. You should know that cos of 2 pi is 1, so this is 1 plus 1 times cos 2 theta. But sine of 2 pi is 0. So that lot disappears. I won't even bother writing it. And of course this is what we had originally, therefore, etc., etc. And the posh answer is now on the screen. So the next property I want to show you is how to find maximum and minimum values of R. Now, for some polar curves, it's really easy, and others it's not quite so easy. So I'm going to give you one that I think is not quite so obvious. So if you were asked when does 1 plus sine 2 theta have a maximum point, if you like, a greatest value or least value, I suppose one thing we'd want to do is think what the graph looks like, and that would perhaps help us decide if it's a hard one or easy one. So this is what it looks like. This is the polar curve. Now you might be able to just look at that and go, you know what, it's pretty obvious what the maximum and minimum is. You can see quite clearly this is the furthest distance it ever gets away, which just looking at the circle is a distance of 2. So if like the greatest value is 2, the least value, well, you can see it actually goes through the origin. Now the origin, if it goes through there, it's 0 away from it, so the least value is 0. When does it occur? What angles does it occur on? Well, you can see just through here that the greatest value occurs at pi by 4 for the angle, 90 degrees, and 45 degrees. And likewise down here, oh, now there it's all the way round to that angle, so this is 3 pi by, is it 3? No, take it back, it's 5 pi by 4. Now, the minimum is not quite so obvious, but you might say to yourself, if this comes round and then goes around into there, you can kind of see that the minimum occurs at 3 pi by 4 and at what is probably 7 pi by 4. So it gives you quite a, greater value 2 at those places, least value is 0 when at those places. Yeah, we were just able to guess that. Now, what if it's not so easy, I suppose, and that's what I kind of hinted at before. What if it's not? And on those occasions you have to use differentiation. Now look at this, it's not quite so easy here. Again, you draw the graph on your calculator and you look at that and you think, well, actually even this isn't so easy. This looks to be, to me, the closest point. That's the minimum, the least value, but it's not obvious how far away it is. I reckon I can do that. That's, well, what's that, 1? I don't even know if these go up in halves. It looks like this is probably 2. And this one here is 1, 2, 3. I reckon that's 4, and this is 2. But again, you could check your scale on your calculator, I'm sure. But certainly the angles are not obvious for the least values. How do we do it then? Well, as this says here, we differentiate. So r equals this, so we can differentiate and find dr by d theta. Now if you do dr by d theta, the 2 disappears. Cos, remember the rule, sine cos minus cos. So this becomes minus sine theta. And cos still becomes minus sine, but it becomes minus 2 sine 2 theta. Now this is equal to 0. That's what we do when we try to find maximum and minimum points. We set it equal to 0. Now if this is true, I've got to solve this equation to find the value of theta. Now there's a little trick here I can do. Now I know the double angle formula for 2 sine 2 theta is actually sine 2 theta is sine 2 theta is in itself 2 sine theta cos theta. That's the formula you've seen in normal maths. So if that's true, you can see I can effectively take out sine theta as a common factor. In fact, I can take out minus sine theta as a common factor. That leaves me 1 plus 2 2's are 4 cos theta equal to 0. And if that's true, either sine theta equals 0 or, well, effectively cos theta equals minus a quarter. And you can solve for that. Notice there are, I'm just going to do the greatest when r is 4. We got that bit right. And theta is 0. Yeah, goes straight across there. Least, this is a bit we didn't know. R is 7/8. Well, we wouldn't know that until we get that. So see if you solve the equation, you get that. Now, my gut feeling is it's this one that does that for us. So if you inverse cos, let's say I'm going to inverse cos that. Oh, I've got about a minute left of this video, so inverse cos, what are we talking on my own radians? Yeah, I think so. Of minus 0.25. I get 1.82. So yeah, so that's done it. Notice there's a plus or a minus because that's the way Cos graphs work. So that's 1.82, and you can probably see from the graph it either go that way round. Now the plus or the minus, I've not really done those minuses. Probably we'd be better off to find that angle and to use the 0 to 2 pi convention. But you get the idea. This is the way we do it. We try to differentiate. Now this is all I've got time for in this video. We'll carry on with this in the main lesson. But this will be definitely a nice start for you. We'll see if we can build on this on lesson and then take this a bit further. Well done.